Geometry section 2.5. We're going to talk about theorems. We're going to, again, continue towards proof writing. We're going to actually write our first proof today for real. And we're going to talk about how something becomes a theorem. In fact, that's the first thing here is, you've heard in a government class or something that has to do with the way our government works, how a bill becomes a law. Okay, I think there's videos, animated videos on YouTube, how a bill becomes a law. Well, how about how a conjecture becomes a theorem? That's kind of what we're going to do today. Theorem, the process goes something like this: make a conjecture, write a proof. If we can prove it, if we can write the proof and to its completion, we can prove the conjecture, then it becomes a theorem. Now, the truth about this is our book is full of theorems. If you look forward into our book is full of theorems. Not everything that we prove will be significant enough to put into a theorem, but how something becomes a theorem is the fact that it can be proven, okay? So we have definitions kind of at the bottom level. We also have postulates, which are all kind of at a base level, that they cannot be proven. They're just accepted statements of fact. We talked about those already. But using these things, properties, postulates, and definitions, we'll begin to write proofs now and build a set of theorems. This is how this works in geometry. We're starting to build upon what we've already known in the language that we've already adopted. Okay, now before I get into this, I also want to say real quick that on your homework in 2.4, in case I don't say this to every cohort, I want to put this in the video. On 2.4 homework number 30, there was a situation where you may not have known what to do. And if you looked at the answer document, you would have seen that they wrote by construction. Basically what that means is that we can draw on a picture. And the reason that you don't know that term yet is because we have skipped the constructions sections in the book. Normally we skip them because we bring constructions back later in the year for kind of a unit of construction. So we've always skipped them. This year we're actually just skipping constructions pretty much altogether because of COVID. So that's just something that for you to know. It's not something that I would put on a test anyway, but you can draw on a picture. So if you do, and it takes a line in a proof, or I guess I should call it a proof, you can write by construction. Okay, let's get into this. In a proof, so I'm down right here now. In a proof, a given list shows what we already know. Each proof will be accompanied by a diagram, okay? Now, here's where we're going to do our first proof. We've talked about what vertical angles are. You already know what vertical angles are. And you could look at this picture and you can see that 2 and 4 are vertical angles, 1 and 3 are also vertical angles. And you might make a conjecture that they are congruent, okay? And that's what we're going to try to do, okay? So the given is that angle 1 and angle 3 are vertical angles, and we want to prove that angle 1 is congruent to angle 3. Okay, so the given should be what we always start with. If they give you givens, I think you should just put them right in to the proof from the start. Our book takes a little bit of a different approach than that, but this is what I think you should do. I guess I should just do this in black, huh? All right, so first of all, everybody should be able to make this wide T-chart. It's not a T-chart like you did in a previous class where it's narrow. Make it nice and wide because we're going to write words in here, okay? Everybody can do that. Everybody can write statements. Everybody can write reasons. This is what we'll do with every proof. And then everybody can write number 1. So we haven't had to do anything yet that makes our brains work, and you can get this far. Not only that, you can go ahead and you can put this given right here. You can say angle 1 and angle 3 are vertical angles. And the justification for that is given. And then you can write number 2. And again, we haven't had to think at all. Okay, now we need to think. What could we do? What would we, as you look at this picture, what would you know? I'm gonna move a little bit faster than maybe you want me to. So if you need to stop and process something, just pause the video. What would we know? Well, we would know that 1 and 2 would add up to 180, right? They form a straight angle here. So we could say the measure of angle 1 plus the measure of angle 2 would be equal to 180. Okay? And that would be definition of supplementary. In chapter 3, we'll be giving you a handout. Chapter 3 is where we really get into proofs. This is really just introductory. We'll give you a handout that's got a bunch of abbreviations like this. Okay, so don't be too caught up on the abbreviation. Oh, I need to know definition of supplementary. There's going to be time for that. Definition of supplementary is not going to be on your chapter 2 test, so don't worry about that. But that is what that would be. Because 1 and 2 are supplementary, I can add them up and set them equal to 180 by the definition of supplementary. Wouldn't angle 2 and angle 3 be that for the same reason? Now, if you want to put line 3 here, then you would have to put a 3 here and say definition of supplementary again. Since it's for the exact same reason, I just put them both under line 2 and then just justify it one time, and we'll have a 3 down here. Okay? Now what? Can you think about it? Here's what you're going to do. You're going to, because this is equal to 180 and because this is equal to 180, these two things are equal to each other. Let me highlight it. Because this equals 180 and this equals 180, those two highlighted things are equal to each other. So that's what we're going to write. The measure of angle 1, I'm going to write a little smaller here to see if I can fit it, plus the measure of angle 2 is equal to the measure of angle 2 plus the measure of angle 3. Okay, now what I want you to think about, and again, pause the video to process if you need to, is why, what do we already have in our toolbox that makes this so? Pause the video if you need to. Okay, I can think of actually two things that would make this so, and I will accept either one. First of all, substitution. A lot of people are going to say, okay, well, if 1 plus 2 is equal to 180 and 2 plus 3 is equal to 180, then I'm going to take this 1 plus 2 and replace it in here for 180, or this 2 plus 3 and replace it in here for 180. Absolutely correct. You can do that. It's substitution. Go for it. I actually look at it as the transitive property, though. If 1 plus 2 is equal to 180 and 180 is equal to 2 plus 3, then 1 plus 2 is equal to 2 plus 3. Okay? And for just shortness of speech, I'm not saying the measure of every time for the angles, the measure of angle. Okay, so I'm going to put transitive property of equality, but if you put substitution property, you're good, because that's what that is. And then finally, notice that there's an angle 2 on both sides of these. We could subtract that off. Whatever the measure of angle 2 is, it's a positive measure in degrees. We could drop that off, and you could say the measure of angle 1 is equal to the measure of angle 3. That would be the subtraction property. You subtracted the measure of angle 2 from each side. Okay? Now, one more thing, an optional step that I always allow students to leave off. To me, this says that they're congruent. When you have measure equals measure, that says that the measure of angle 1 is equal to measure of angle 3 is saying angle 1 is congruent to angle 3. But some teachers will require this. Angle 1 is congruent to angle 3, and that would be the definition of congruence. Okay, I always leave that off. This is an unnecessary step in my opinion, but other teachers may disagree. So that's your first proof. Give yourself a pat on the back. Now, here's the thing. We're moving on now. We're almost done already. Here's the thing. Now that we've proven that vertical angles are congruent, oh, and by the way, you can mark that on your diagram too. So now I've proven that angle 1 is congruent to angle 3. Okay, and they weren't any specific angles. They weren't any, this isn't just an anecdotal proof. This is proof now for all vertical angles. It doesn't matter the way you drew it. Vertical angles would be congruent. I could have done the same proof on 2 and 4. In fact, 2 and 4 are going to be congruent as well, and this is how I could denote that, right, with 2 arcs. Now that we know that, we know that vertical angles are congruent, it's a theorem, and here's your theorem, vertical angles theorem. Vertical angles are congruent. Now, you've probably already known that because it's a simple one, and we kind of touched on it in chapter 1, but now you know it for sure. We have something that we can cite in a proof that is the vertical angles theorem. Okay. Now, who likes abbreviations? I do. How about for the vertical angles theorem? How about VAT? That's how we're going to abbreviate the vertical angles theorem. And the point is that you don't have to go through this 4-step proof now. When given a situation where you want to use vertical angles, you can do it on one line of a proof and just cite it with the vertical angles theorem, VAT. Okay? Now, an example. One more example, then we're just going to run through the last of the theorems, which are all simple. Here's another way that you can apply vertical angles to a problem. this is not a proof, this is just an algebra problem. We would know that this angle is congruent to this angle. Therefore, you can go 2x plus 3 is equal to 4x minus 101. Okay. Notice they did not say justify each step, so you don't have to say, this here. But we could say this angle is congruent to this angle by vertical angles. This is, 2x plus 3 is equal to 4x minus 101. That would be substitution, and then, justify your algebra steps. Anyway, let me just roll to their answer here, because we've seen many problems like this. And they get x equals 52. By the way, you could plug 52 back in for x. This would be 104 plus 3, so 107. And 52 here would be 208 minus 101 would be 107. It works, right? Okay, finally, I just want to briefly touch on the other theorems that are in this section that we don't have the time to write proofs for, and they're very, very basic. The congruent supplements theorem says if two angles are supplements of the same angle or of congruent angles, then the two angles are congruent. Basically, if I can just use the diagram above, if this angle is supplementary with angle 2 and this angle is supplementary with angle 2, then angle 3 and angle 4 are congruent. That almost mimics exactly the vertical angles theorem that we just proved. Okay, so that should be an obvious one. Congruent complements theorem is the same thing, but with 90-degree angles. If two angles are complements of the same angle or of congruent angles, then the two angles are congruent. Should be obvious. How about this obvious one? All right angles are congruent. Congruent means equal measure, so all right angles have a measure of 90 degrees, so all right angles are congruent. And then lastly, this last one says if two angles are congruent and supplementary, then each angle is a right angle. Think about that now. We've got two angles. They're congruent, and they add up to 180. They're the same measure, and they have a sum of 180. Wouldn't that mean that they would have to actually be right angles, 90 degrees and 90 degrees? If two angles are congruent and supplementary, both things, then each is a right angle. Oh, yep, that's all. Thanks.